Question number 10 is solving linear inequalities. We're first going to use the distributive property to break down the parentheses, then we're going to collect our like terms. We're going to isolate x, and I'll put a little plug in here, just a reminder that anytime you're working with inequalities, if you multiply or divide both sides of the equation by a negative, to make sure you reverse your inequality sign. So first thing I'm going to do is distribute the negative 2, so it's 5 minus 6 plus 2x, because the negative times negative is positive, is greater than or equal to 5x, and now I'm going to distribute the negative 3 to the x, which is a negative 3x, and negative 3 times a negative 1 is a positive 3. Then we're going to collect the like terms on each side, and negative 1 plus 2x is greater than or equal to 2x plus 3. And then we're going to start collecting our like terms on opposite sides. So I'm going to add the negative 1, so I'm going to add 1 to both sides to undo that. So I'll have 2x is greater than or equal to 2x plus 4. And now when I go to try to collect the like terms with the x's, I'm going to subtract 2x from both sides. These x's drop out and these x's drop out, so you really have 0 is greater than or equal to 4. So if 0 is greater than or equal to 4, it's kind of an odd looking solution set, and number 1, it's false for anything because 0 is not greater than or equal to 4. So because this is false, and because all of our variables are x's dropped out, no matter what we put in for x, it's always going to be false. So which of the following describes the values that satisfy this inequality? There are none. There are no real numbers that satisfy this, because no matter what we put in for our x, these x's back in the original, even after we distribute, or even before we distribute, no matter what we put in there, they'll drop out and we'll end up with a false statement. So there are no real solutions to this, which means it's virtually impossible to find a value of x that will make that inequality true.